fur. And fur is a package that combines futures with the per package, which I'll cover in just a second. So it makes it like insanely easy to set up parallel processing. Now, just because it's super easy doesn't mean that you should always be doing it. But so wait, before you get started, instead I want you to type out at the top library tidyverse. And then replace future with fur. So FURRR, 3 R's. Yes. Excellent. And then I want you to add library. So we want to have a data set. So I think we did this last time. Palmer penguins. So PALMER penguins. So PENGUINS. So you might have to install that. So yeah. Fabulous. I don't know if it's just me, but is your screen really small? Is it half-sized? Oh, there we go. That makes sense now. Okay. Okay. Yes. Okay. So now the very first thing that we just want to do is just to be able to see like what are the columns inside of the penguins data set. So if you type out penguins, pipe, so Control Shift M for pipe. Control Shift M. Yeah, perfect. And then create a new line and then type out names and then run that. So inside of this data set is a set of like penguin species, like the islands that they were recorded on, and different like weight and different measurements that were done, as well as their sex. So the next thing I want you to do is I want you to go penguins, so right now what maybe I'll take a step back here. Even though you can do, yeah, no problem. Even though you can do a lot of different things with parallel processing, and it's really just your creativity that is like limiting you. I would say that, at least in my experience, the times that I've used parallel processing are either for loading in a bunch of data. So like you have a bunch of data files and they each take a long time to load in. So then you run parallel processing to be able to load them in faster. The other way that I've personally used it is if I have a bunch of models that I need to run. So like, let's say I have 20 different models that I want to run, and each of them take a little bit of a time. Depending on how big your data set, they can sometimes take a little bit of time. And so I want to run them in parallel so that they get finished faster. So in this particular case, what I want to show is running some like statistical tests on this data set to see different things based on it. So this is the motivation, is like you want to run a bunch of statistical tests on a data set. How can you do that quickly, and how can you do that while using parallel processing? So the first thing we'll do here is if you go back to penguins. So what I want to do is I want to find how, and this is just purely an example, but I want to find how body mass might influence or like it might be related to the bill length or the flipper length or whatever by sex. So let's start with that. So what I want you to do is I want you to pipe. So Control Shift M, and then create a new line, count, because right now I just want to count to see how many species. So yeah, go back inside of the thing. I want you to do species, comma, sex, just to get an idea of what we're working with here. Then Control Enter. Yeah. So we can see that like within each species and sex, like there's a decent number of things, but there's also some that are missing. So what we will want to do is we want to actually drop those missing values from when we run our models. So let's go create a new line. And I'm going to start telling you like how to what I'm going to do right now is I'm going to tell you how to start writing it, but we actually have to take a step back afterwards, and I'll explain why in just a second. So what I want to do is I want to run a model on female and on male. So it's only two models. It's nothing complicated, but it could be something else. Like we could run a model on species, which is then 3 instead of 2. Or if you have like, I don't know if anybody does analyses on bacteria or anything like that, you can, do this, like you probably will have so many more species than you could do different models based on each of the species. So just because it's 2, it could also be 3, it could also be 100. This what I'm going to be showing you. It doesn't matter about how many there are. So I want you to do penguins, pipe, so Control Shift M, then create a new line, and I want you to say drop underscore NA, because we want to drop the, so underscore NA for missing, and then sex. So that's going to drop sex. Then I want you to go to the next line and pipe on line 13. And the way that FIR works is it uses the functional programming approach, which several of you have encountered in the intermediate course that I taught this summer, before summer started. And so what that means is we're going to give it to the function called map. And so what map does is it says, okay, you have a set of objects, and I want to run a function on each of those objects. So in this case, the set of objects is the male data set and the female data set, and I want to run a linear model on each of those, a statistical test on each of those objects. So the way that we do that is first, we only have one object right now, which is a data set, but we need 2 objects. So the way we do that is by splitting it up. We can use the function called group underscore split, open close bracket, and then we'll do it by sex. So if you Control Enter this line just to show you what it looks like, and then if you scroll in the console, you now see that there's 2 objects. You see there's 1, you scroll down, there's 1, and then there's 2. So now we have 2 objects. So what that means is now we can use the map function to then run it on each of the data sets. So if we go back to the end of line 14 and we pipe, and so create a new line. So normally you would say map, but so I'll get you to write out map first. Open close bracket from the per, yep. Now here is where it is a little bit tricky. How I'd mentioned that I'm going to tell you this first thing, and then we have to actually go back. The way that map works is it's best that you give it a function, because you're saying, I want you to do this action on these 2 objects, which is the male and the female data sets. In this case, we want to say, I'm going to get you to create a function called tidy_lm, so for tidy linear model. So I want you to just write that in right now. It won't work, but I want you to write it in right now. So tidy_lm. Yes, and then that's it. That's all you do. So what that will do is it runs the statistical test on each of those objects. Now, here's kind of the cool part. This won't work because that function doesn't exist yet. But so let's go to line 11. And then we're going to actually make then the function. So it's called tidy_lm and then assign. So the arrow, yep, a function, open, close. In this case, we're giving it a data set. So we have to give an argument called data. And then go.
Sorry.
Yeah.
I remember that you taught a shortcut to create functions.
The function, yes.
Yeah. What was it? I didn't remember.
I can show that afterwards because I'm gonna make another function in a second. Yep. So I'll show that. So now inside of the function, what we want to do is we want to run the linear model, but then also tidy it up a little bit because like the linear model on its own is it's a big object and we just want to tidy it up and get just the things that we want. So I'm going to get you to write out results and then assign and then LM for linear model. And right now I'm kind of curious about how body weight influences bill length. So I'm going to tell you to do bill_length_mm. So bill, BILL underscore length, LEFNGTH underscore MM for millimeter. And then I'm going to get you to do the tilde. So in the linear model, tilde implies like equals to, or it sets it. It's a formula now. And then do body underscore. Well, first the tilde. Yeah, perfect. Body underscore mass underscore G for grams. And then we have to tell it what the data is coming from. So we do comma, data equals data. Yes, you got it. So then the next thing here is we want to tidy up the results object. So we're going to use a package called broom. So create a new line and call broom : tidy. You got it. And results. So then now go to line 16 and do Control Enter. And now do Control, yeah. So now we know, now we've just run a linear model on 2 objects. And the nice thing here is that you can, it doesn't matter how many of the objects there are. Like, so you could change sex to species, you could change it to something else, and it will run it on every single one, regardless of how many there are. So it's a very clean way of doing a lot with little code. So now here's the cool part. Making it so that it's doing parallel processing is as easy as go to line 17, and we're going to type out plan, so PLAN, open close bracket, and then say multi-session, all one word, MULT, yep, session, without the open close bracket, just by itself, yes. Control Enter, and then go down to map and replace map with future underscore map. So the only thing you add is future underscore. So now if you run this code again, it's not going to change anything because it's actually, in this particular case, like parallel processing will be slower because there's only 2 objects. But this is how, now we've just done parallel processing in R, is you add these two lines of code, future underscore and map. Future underscore and the plan. And the plan is to tell R, how do you want to do the parallel processing? And there's different options. There's really only two, basically, multi-session and sequential. And so it's always good practice to anytime you start up parallel processing to close it off again. So at the very end of the line 24, I'm going to get you to write out plan sequential so that we can convert it back to being a sequential setup rather than, without the perfect. So now, basically what we've just done is we've taken a data set and applied, what we've just done is we've just set up something so it's now parallel processing. So what I was going to say is, in this particular case, you might have noticed that it was a little bit slower than when you used map. And that's because when you have a small number of objects, the very first things with parallel processing is the parallel processing has to create multiple sessions, R sessions, and then it'll run everything. So that creation of the multiple sessions takes a little bit of time. So when you have a small number of items, it's better to do sequential than it is to do parallel. But when you have something that takes a long time, so sometimes your statistical tests might take a long time, or sometimes loading in your data set might take a long time. So it's in those cases where the time that is spent on computing, like on the computation, is more than the time it takes to set up the parallel processing. That's when it gets a benefit. So usually, like in this particular case, you probably wouldn't see a benefit until you have like more than 50 models of this size, or like maybe like 20 models if they each individually run a long time. So it's basically, you don't always want to be doing parallel processing. It's only sometimes where you want to be doing parallel processing. But if you do need to use parallel processing, it's really, really this easy. Now, I don't want to just stop here because there's actually several other things that we can do here, because I want to be showing off how to run multiple models, not just on a data set, like on specs differences, but also like if you have different formula that you want to run on. So for instance, we want to run on body mass with the flipper length or something like that. But before we continue, I want you to run line 20 again. And I want you to see here, first off, it's in two objects, so that makes it a little bit more harder to work with. So I want you to do at the very end of line 23, I want you to pipe and create a new line below that. And then I want you to type out list underscore rbind. Yeah. Now, if you run that, now we have a single data set that it's much easier to work with. So if we want to like be able to plot this or something like that, it's a little bit easier. But let's look at that object for just a second. There's term, there's estimate, there's standard error, there's statistic, and there's p-value. But we're missing something here. We're missing the information on what is that actual model that is being run? What is the body mass of? Like in this case, we personally know that the first object is, I think it's male, and the second object is female, but we don't know. So the way that we can kind of fix this issue is if we go into the function at the top, the tidy lm, and at line 15, you do pipe at the end of line 15, pipe, and then create a new line, mutate, open close, and then you can say, in this case, sex equals, and then this is the tricky part. Because we're taking in the data object, we have to extract the sex information from the data object. So we have to do unique. So UNIQ, open close bracket, data, $, sex. So we're saying we know that there's only one sex variable in there, which is male or female, because it's being group split by that. So we're saying take that information and then add it to the tidy model output. But the way that mutate works is it adds it to the end. So what we actually want to do is we want to put it to the beginning. So if we do go on the other side of the comma after sex of the bracket, so one more over, comma, and then dot before equals everything. So what that says is put the newly created column before everything. So now if we run line 18 to get the object, and then now if we run the next set of stuff, now we have that extra information of being sex is the thing before. So we know that the first model is female and the second model is male, and that makes it a little bit easier for us to work with things. So that's how you add some information to the model when we run it. But this is a very basic example. And there's another way, I don't know about anybody else, but for me, when I do, when I run models, usually it's on multiple different models of checking one thing versus something else rather than splitting up a data set by itself. So in this particular case, what I want to be doing is I want to run a model where one of the variables changes each time. And so we're going to create a new function. We're going to call it tidy _LM _x, xvar. Do we want to do xvar or do we want to do yvar? No, let's do yvar. Let's do yvar. Y V A R. V like vindictive, not D. Yeah. Or violin, so AR. And then create it as Nuria, sorry. Delete this. I want to show this thing. So delete this and type out fun, FUN. And then this thing pops up and press tab. Yeah, there you go. So now do tidy. Yeah, and then tab. You should be able to automatically tab to the next. No, never mind then. Then go to variables, move it over to the variables. And instead of variables, we want to call it yvar. Yeah. So then now inside, there's this nifty little. So the thing with the linear models is if you scroll up to the top to the other linear model, you'll notice how it goes bill length tilde body mass G. So unfortunately, there's no easy way to add in another variable there because it's a formula and formulas are set as what they look like. But there's this nifty function called reformulate, which makes it a little bit easier to generate multiple formula. So we go back down there and we type out reformulate. So reformulate, open close bracket. And here we'll put in C, open close bracket, and then quote body mass _mass _G. And so the reason why I set it up C is because I want to add sex later, but I don't want to do that just yet. And so this will be on the x side of the equation. And then go over. Wondering if I should just show you what this looks like. If you go to your console, I want you to just show you what this looks like. So go to your console and type out reformulate, open close bracket, quote, body mass, G. And then wait, before you finish, then click up so you get the thing back again, the up arrow. Yep, and then go inside and comma, response equals quote bill underscore length underscore mm. Enter. So now you see that it creates a formula for you. And the reason why we want to do that is because we want to give a future map a list of variables that we want to create models for. And those list of variables will be character variables. As you can see here, anytime you do the quotes, that's going to be a character. So that's what we're going to be doing here is if we go up to the line 34, and after the in between, do comma, response equals, but instead of bill length, we're going to do yvar. Without the quotes this time, because we want to pass the argument to that. And the yvar will be a character, so when it gets given to the response, it's going to be a character. At this point, it's not a character, it's an object. So that's what, now we'll be able to create a bunch of formula based on that. So now if you go to the beginning of the line, we want to assign this as an object. So go to the beginning of the line and of line 34. Do model underscore formula. Yeah, great. And then create a new line underneath. Yes, there. And then do results. And then do LM model underscore formula, comma, data equals penguin. Penguins. And then now we're going to create a new line under that, and we're going to tidy it up again with broom. So broom, : tidy. Results. And then now we don't need to pipe actually. In this particular case, we don't need to pipe. So now actually, yes, we should pipe and mutate and then the bottom. And in this time, instead of saying like sex or anything, we're going to say yvar equals. And in this case, we don't have to do that because the object that we're going to give is a single character. So if you do equals yvar. And then run the function. So go to line 39, enter. And we can test this out right now, actually. If you go to the console and type out tidy underscore LM underscore yvar, and we'll quote bill underscore length underscore mm. Now we'll get a, we should actually add the, so we know it works, but now we also noticed that we should have added the dot before after the, dot before equals everything. Has anybody seen the Everything Everywhere All at Once? Oh, it's a great movie. Highly recommend it. Okay, so now we have this set up. We know that it works. Let's then apply it to the to using future map. So what we're going to be doing is we'll copy the plan. Now, instead of what we did before was we had the data set, but this time we're not going to do that. What we're going to do is, if you scroll down, what we want to do is we want to give it a list or a vector of variables that we want to run the model on. So in this case, let's start off with C, open close bracket, quote, bill underscore length underscore mm. And we'll add one more just so we can see that it works. So go on the other side, comma, quote, bill underscore depth underscore mm. And then go to the end, pipe. And then we do future underscore map. Open close bracket, tidy underscore lm underscore yvar. And then go to the end and pipe and do list rbind. And then now run that control. So now we see that and now we see that that we can run, that it works, that we get two models. And let's add another one. So let's go to line 44, do comma, quote, flipper underscore length underscore mm, and run that. So now we have three models. So you can keep doing this. You can keep adding stuff to what you want to be, the models that you want to run. And it's very then easy to, have a long list of, if you have a bunch of metabolites and you need to do a quick thing of how many, what are the associations with all of the metabolites, just as an example. This is one way of being able to do that. And we always want to end it with plan sequential. So we want to bring it back to being a sequential session. Exactly. And the other thing, oh yes. So you'll notice how in line 34 I kept the C there, right? And now I don't know how much you know or from your statistics training, but when it comes to modeling and statistical analysis, oftentimes you want to adjust for things. You want to say well, we know that there's an influence of this factor on the association, so we say what is the association after adjusting for the thing. So in this case, we have sex. So what we do is inside of the C at the end, do comma, quote, sex, and then we run this function again. So on line 41, and then run the future map. And now we see that we have an extra row called sex male. And that gives us, then now we know the relationship that we see between body mass and the bill length or the bill depth or whatever is adjusted for sex. So we can add more variables in there if we want to. So that's kind of how and I think this is basically all that I was going to cover. The only other thing that I wanted to highlight, and we don't need to do this right now, but maybe it might be relevant for other cases, is after, when you bind them together, sometimes you don't have that information on what's the object or whatever. So you can actually say inside of this list rbind, you say names underscore 2 equals quote, so that we were creating a new column that recognizes that each of the items are a unique thing. So we'll say like model underscore ID. And in this particular case, it's going to give us back the a set of numbers just representing the model ID. So we see that there's 3 models. So it's an easy way of sort of getting a sense of how many models you ran, and a little bit easier to look at to say, okay, there's like the model, the first model, the second model, and all that stuff. That's all that I have to cover about parallel processing. As you can see, it's pretty easy to do because it's only a couple of small code changes. But once you get working with like much larger data sets or with like thousands of models, let's say, maybe not in the level of like genetic analysis, but it's still quite a lot of models that you have to run. This is super helpful, especially if you're in like a cluster or like a high performance computing environment where you can like make use of all the CPUs that are inside of the high performance computing environment, rather than just using the traditional one. So yeah, that's all I have. Does anybody have any questions? You should have seen it before Future Fur came around, and even Future. Like it was still like relatively easy compared to, if anybody is familiar with Python. It's Python has only now recently allowed you to do parallel processing, but before you couldn't even do parallel processing, or it was extremely difficult to do, at least compared to R. And now with R, it's just so easy to do parallel processing. It's like, yeah, incredibly easy to just throw in that line and it's done. Yeah.
I have a question. So if I want to rename each model, change the model ID to like other names that I want, how do I do that?
What other names would you like?
Like, just for example, change the 1, 2, 3 from numbers to like characters 1, 2, 3. Like manually rename them.
I think there's a way to do it inside of. You'd probably have to do it afterwards. So you'd probably have to like pipe to. No, there's no other option, sadly. But you'd pipe and you'd mutate. So if you wanted to change it to a character, you'd pipe. And then mutate model ID, model underscore ID equals. No, you don't have to do it.
Oh, yes.
Yeah. Equals as character, as dot character.
Well, I mean, like, if I want to change it to like some other names, what do I do?
Oh, the name, like the variable name itself.
Yes, like I want to change one, let's say to BO1.
You'd probably have to do that manually. Like, so if you can do that here. So we'll, instead of as character, delete that and do case underscore when. This would get a little bit complicated once you have way more models, but if you only have a couple, then it's not too bad. So case underscore when. Yeah. Open close bracket. And then create a new line. And then do model underscore ID equals 1 tilde. 1, like the number 1. The number 1. The letter or the character 1, or no, the number 1. So just on the keyboard 1. Tilde. It's a little tricky on some of those Scandinavian keyboards. Quote bio_1 or whatever you want to call it.
Oh.
Yeah. And then control enter, and that will manually rename it. I don't know if there's like, another easier way to doing it. Oh yeah, right. And then comma. Yeah, you can rename it like that. Alternatively, if it's always Bill 1, then you can add it to the beginning of all of them if you wanted to.
Like this or?
No. So in this case, if you wanted to add Bill to all of them, so we'll delete case 1 entirely. So delete case 1 all the way down to the end. Yeah. And then do str_SSTR, like street, str underscore I guess you could do, would that be the easiest? No, maybe paste would be better. So let's delete paste. Bill. Yeah, actually C quote. So C open close bracket quote Bill outside of the not Bill 1 yet, and then go outside and do comma. But inside the C. Yeah, comma. Bill model underscore ID without the quotes. Model underscore ID.
Model underscore ID?
Yes. And then we'll delete the comma at the end. And then if you run this, that should...
Maybe I need to repeat it 9 times.
No, okay, wait. Maybe that's getting too complicated. Let's delete the paste, and we'll do it the way that I originally was saying. Do str, so delete all the way up to the equal sign.
Mm-hmm.
Str underscore replace model underscore ID, comma, quote, and then we want to put it at the very beginning. So what we're going to do is we do uptick. It's the little hat thing. I don't know what it is on your keyboard.
Okay, so it's...
Yeah, there we go. Yeah, and then go outside of the quote, comma, quote, Bill. There, that will work. Yay, there we go. So string replace is saying, the uptick is saying at the beginning of at the start of the whatever string or whatever it is, add Bill to the start. That's what that's saying.
Okay.
But you'd have to do this manually, and there. I think there's like ways of doing it, but I'm not 100% sure.
I have a question, Luke.
Yes.
If you want to add apart from H, like other like computers, you need to change manually every here. Add manually, and then maybe change each function for
Oh, if you wanted to run, like if you wanted to do them, like if you wanted to do several models with several different types of adjusting variables. Yeah. So then in that case, what I would do is I would add, I'd make this function a little bit more generic. So right after the yvar, like let's do that actually. So if you go to the beginning of line 33, if you go to line 33 and inside of the function do yvar, after yvar, line 33, comma, confounders. And then inside of the, replace sex with confounders. Yep. And then if you scroll down, then inside of the tidy, the future map. So first, let's run line 41. Yep. And then inside of the future map, you do, before doing that, first you have to go to the beginning of the tidy and then do tilde, because you want to say, I'm passing this a function that is already doing some stuff, but don't do it just yet. So tilde. And then after yvar, open close bracket. And then .x, so that's saying put whatever is being given to map into this position, comma. Confounder, I think it's, confounders equals quote sex. And then you'd run another one. You'd have to run this again. Like you could probably do this a little bit like complicated where you set it up so that it all does it in one go, but probably just doing this one by one probably would make the most sense.
So the future map, the first object that piped into the future map will be used as this .s here.
You bingo.
For other variables we specified. Manually. Yeah. Okay.
Yeah. That is right. Yep.
But then, if you want to add another one apart from sex, it would be to add it next to, here.
Yes, in there,
Open quotes again? Or?
Yes, you do C, C after, before sex. Well, we don't have anything to really, I mean, I guess you could do like island or year, but you do like the C, sex, and then you'd add other stuff.
Okay.
Yeah.
Thanks.
Yeah, there's like other ways that you could, like if you had several, like if you had more than 3 of this, like if you were running more than 3 models that were adding these things, then I would say there's probably an easier way of doing that. Well, there is an easier way of doing that. It would just require you to take a step back and think about the structure of the formulas to begin with. So you'd start, you'd have to take a step back first, but it's possible. It's definitely possible. And I think there's actually some functions that will do that for you. It'll do like all different, like packages, but sometimes I think they're a little bit slow. I've used some of them and they're a little bit, like they're really good for a specific purpose, but like it's not super flexible in what you might want to do. So, yeah.
I see. Isn't that like, for me, I usually use just paste and to write the formula first and then put the formula inside the function.
Paste also works. You can definitely use also paste. I think maybe the reformulate is nice because it's specifically like the as you add like more variables, it will automatically add plus signs. So for instance, with this reformulate, when you add the confounders, it automatically adds the plus signs. But with paste, you'd have to manually add the plus signs. So this function is specifically designed to make a formula, basically. But paste isn't. Paste is a generic function. Any other questions?
I have a question, but I don't know if it's like a little bit off topic, but for example, on the result table that you have like several estimates, right?
Yes.
For body mass and for sex. What if you like are only interested on the, I don't know, body mass, and you want to get the body mass for all of them, for all the models? Is there an easy way to extract it?
100%. You keep on using dplyr verbs like filter, so we can actually do that. So if you go to line 61 and pipe filter open close term equals, and then just one equal. Oh no, sorry, it's filter. No, you're right. Filter equals body mass G. And that will filter confounders as missing, right? So you have to. Yep, exactly. And there you go. Then you just have the estimates for the body mass.
Thank you.
Yeah. Yeah, as soon as you just when you just start thinking of like, okay, let's get this data set, let's get the results into a data set. And then because it's now a data set, it's a data frame, you apply dplyr verbs to it and you can do whatever you want to it. So it's, there's nothing special about the results versus other stuff versus like the original data. Okay, so